Hi, Maurits here again. In this video we should look at the binomial distributions. That is the first real new thing in this section, I would say. And the binomial distribution is a particular distribution that is quite useful. And we know if we have a binomial distribution, if there is an experiment or something where you have two possible outcomes, either success or fail. There could be other things, it should be two, but often it's called success and fail. And these should have some fixed probabilities. So the probability for success should always be some value p, and the probability for fail, that usually is called q, is then of course 1 minus p, because those two should add up to 100%. An example of such things could be you throw a die, the success is to get a 6 and a fail is to not get a 6. You buy a product, a success if it's working, a fail if it's not working. So anything with two outcomes where you have a fixed probability. And you should do several attempts because it must be something you can try over and over again. And usually we use the variable n to indicate the number of attempts. So for example, if you throw a die and you throw it 6 times and the success is to get a 6, then the number of attempts will be, say, 6 attempts. Or if you do 10 throws, it will be 10 attempts. The corresponding random variable, x, is how many successes we have in n attempts. So for example, if I throw the die 10 times and I get 6s in 2 cases, then the corresponding random variable here, x, would give us 2, because we got 2 6s in 10 throws. And the goal of this video is to find the probability of getting r successes in n attempts. In other words, the probability of our random variable is r. So for example, we could try to figure out what is the probability to get, say, 2 6s in 10 throws or something like this. So that is what this little video will be about. So I think this will make most sense if we look at an example. Say we throw a die, and what we call a success is to get a 5 or a 6. So we can see here that the probability to get a success is the probability to get a 5 plus the probability to get a 6. So that would be 1 out of 6, the probability to get a 5, plus 1 out of 6, the probability to get a 6, that would be 2 out of 6, or 1/3. That also means that the probability to get a fail equals to the rest of this, that would be 2/3. And as we said just a moment ago, we said that the probability to get a success, we call that p, and the probability to get a fail, we call that q. And say that the number of trials here, n, equals to 5. So we throw this die 5 times and we will see how many successes or fails we get. And suppose we are to find out what is the probability that our random variable x, remember x now means the numbers of successes, so the number of times we get a 5 or 6, and we say we want to know but the probability that is equal to 2. In other words, if we throw this die 5 times, what is the probability to get either a 5 or a 6 2 times? So we could, for example, get 5, 2, 3, 6, 1. That is a way to get a 5 or 6 twice. So we could, of course, get a 6, 6, 1, 1, 1. That is another way to get it. And there's many ways to get this. So when we throw this die, we could, for example, get this result by getting a success and then a fail and a fail and a fail. Or we could have, say, a success and a fail and a fail and a success and a fail. Or we could have a fail and success, fail, fail, success. There's many ways to get 2 successes out of 5. But let's start with figure out the probability for this one. So we can see the probability to get a success, that was 1 out of 3, times, since we take one of them and the next, we multiply, So 1/3 times 1/3 times the probability to get a fail is 2 out of 3. 2 out of 3 again, and 2 out of 3, since the probability doesn't change. So in other words, these events are independent. You can see this become then 2 to the power of 3 divided by 3 to the power of 5. So we can take our calculator, and there we write 2 to the power of 3 divided by 3 to the power of 5. So that will give us about 3.29%. So we write that here, 3.29%. So that is the probability that we will get success, success, fail, fail, fail. But what is the probability? So you can say that is the probability for this. But what is the probability for this thing? Because that's another way to get 2 successes. And we can see that will be exactly as big, right? Because that will be 1/3 plus 2/3 plus 2/3 plus 1/3 plus 2/3. And since the order of multiplication doesn't matter, it must be the same result as the previous one. And the same thing with the next one, and the next one, and the next one, however many this might be. So in other ways, we need to figure out how many ways we can get these different results. And if we look at this, we can see that, oh, that's, and how many ways we can select 2 from 5. Because we should select 2 positions for the successes to be among these 5. I think we've seen that before, right? In the chapter earlier about combinatorics, and then we used that in the binomial expansion, we had this choice function, right? That from 5 choose 2 that we can use. And if you remember what this was, that this will be 5 factorial divided by 2 factorial times 3 factorial. And if we expand this, the normal way to do that is, since we can write this as 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. This part and that part will immediately cancel, so I wouldn't even bother to write the first part. Instead, what we do is say 5 over 2, okay. We often read that as 5 over 2. So, or the 5 choose 2. So I would take the lower number, write out its factorial, and then I take the upper number and write equally many factors of its factorial, so that would be 5 times 4. So that would be 5 times 4, right? So we can cancel a little bit here, so that would be 5 times 2 left, so that would be 10. So in other words, it's 10 ways to select 2 successes out of 5 trials. So that means that our total probability, the probability that x would be equal to 2, equals to 10 times the 3.29, or 32.9%, and we have solved the problem. This we can generalize. We can basically look at what we did here. We can write this first, what we actually done. We have taken from 5 choose 2 times the probability to get a success twice, that will 1/3 to the power of 2, times the probability to get a fail, that is 2/3 to the power of 3. Observe that these two numbers, the two powers, always add up to the first number here. And that was, now we found that was 32.9%. If we look at this in general, we said that we do n trials, so we should try to find a formula for if x equals to r, where we have done n trials. That will give us that, okay, from n trials instead of 5 trials, we have r successes instead of 2 successes, and instead of 1/3 in general, that will be probability p, right? The probability to get a success to the number of successes we have, times 2/3, that corresponds to q now, the probability to get a fail, times that number and we can see that 3 is 5 minus 2, in other words, n minus r. And this, my apprentices, is the binomial distribution formula. It might look intimidating at first, but we'll saw here how we got to it. It was fairly straightforward. We should look at some further examples in the next video. Thank you.